Hey everyone, welcome to this lecture. Here we are going to talk about OSPF on your Palo Alto firewalls. So we will configure OSPF on your Palo Alto firewalls as a IGP based routing protocol. But before we go ahead and do the configuration, let's talk about the basic fundamental features of OSPF, which everyone should know as a network engineer. So let's talk about the key points of OSPF, and then we can do a deep dive with the configuration expect on Palo Alto firewalls. So first thing first, when you talk about OSPF key points, so as we all know that OSPF, it's the full form is open shortest path first. Okay, so this is usually abbreviated as OSPF, which is an IGP. So it's an IGP, and it's a link state routing protocol which is used in IP networks, right? So and is an link state routing protocol used in IP networks, which could be IPv4 or IPv6 based networks, right? And it is the one of the common used as an open standard protocol for doing dynamic routing. So it supports multi-vendor. So for example, I've got a Cisco router and I've got a Palo Alto firewall, right? I want to exchange OSPF routes between those two type of vendor devices, so I can do that. So yeah, it is vendor agnostic, so that's the reason OSPF is highly deployed across multi-vendor environment. So first point, let's say regarding OSPF, let's say basics that we think about. So what are the different basic points that you must be aware of? Okay, so first is type. Regarding type, so basically it's a link state routing protocol and it is an IGP. Okay, so it is link state routing protocol and it is classified as an interior gateway protocol. The second point could be the algorithm. So what is the algorithm that it supports? So it supports something called as Dijkstra or Dijkstra, whatever way you can spell it. So it's called as Dijkstra's SPF, which is called as shortest path first, that is SPF algorithm. Okay, like RIP has Bellman Ford, so similarly OSPF uses Dijkstra shortest path first algorithm to calculate its best path. So the administrative distance, or you can say AD value of OSPF is 110, which is lower than RIP but higher than EIGRP. Okay, so I can say that lower than RIP but higher than EIGRP protocol, and it is lower than ISIS as well. So lower than RIP and ISIS, because ISIS is having an AD value of 115. Okay, yep, so it uses the routing updates using a multicast address. So it has got multicast based updates, rather broadcast of RIP v1. So it uses a specific multicast IP of 224.0.0.5, which we call that as an all OSPF, or you can say all SPF routers. Okay, and it uses another IP which is 224.0.0.6, which is all OSPF DR/BDR routers, right? So whenever any OSPF router is sending its update towards a DR or towards a BDR, then the destination IP of that update packet is 224.0.0.6. But whenever any other routers is sending its update to, for example, a DR BDR is sending its updates to the normal SPF or OSPF routers, the update would be sent using 224.0.0.5. Okay, So I hope all of you know what is OSPF and know the basic features of it. It is just important features or key points that you must remember as an engineer, right? So with that in mind, we are discussing in this way. Yeah. So metric basically it uses cost or link cost parameter, which is used as a metric calculation parameter to calculate the best path, right? So it is cost as the metric parameter, which is calculated based on bandwidth, based on link bandwidth. So there is a formula where you can say cost is equal to 100 as a reference value by the bandwidth in Mbps. Okay. All right, so regarding OSPF areas, and we can say the hierarchy. So okay, so what are the important points you must remember is OSPF has got the concept of backbone area, which we call this as an area 0, and make sure that it must be present and all other areas must connect to it, right? So must be present and all other areas must connect with it. So the idea of backbone area is to connect or attach other areas. Okay, then we have different area types, like we have stub area. So in stub area it will restrict any external routes to reduce overhead, right? It restrict any external routes to reduce overhead. Okay, we have got totally stub area, totally stub area. So the idea of this, it was going to block both external and summary routes, external and summary routes. That means it will block both LSA type 3, 4 and 5 for totally stub area, but in case of stub area it will block LSA type 4 and LSA type 5. Likewise, we have got not so stubby area, right? Not so stubby area. So here it will allow limited external routes, it will allow limited external routes. Okay, and there are specific design cases that you take around and you work with that. Now we have the respective sections on CCN and CCNP course, where you can go and go through that deep dive of OSPF and understand how those individual component work. All right, so next point is you must remember with OSPF router types. Okay, so in router types we have the OSPF designated with different router types. So we have internal router, which we call that as an IR. So all interface will be part of the same area. So all interfaces in the same area ID, they are called as internal router. Then we have got backbone router. Okay, so let's say it's BR, so router which is only located or part of area 0, so you can say located in area 0. Then we have got ABR, or we can say area border router, which is ABR. So it connects multiple OSPF areas together, connect multiple OSPF areas together, right? But make sure that one of the interface for that ABR should be in area 0, then only it is called as an ABR. Okay. Yep, then we have got autonomous system boundary router, which is called as ASBR. So the idea of ASBR is for redistribution, so it connects OSPF to external networks. connects OSPF to any external networks by allowing redistribution of external routes into OSPF area. So the router, so there is a router which connects to OSPF, the same router connects to BGP, and if you are doing the redistribution of BGP routes into OSPF, that router becomes an ASBR. Okay, so the redistribution based router is becoming an ASBR, redistribution. Yeah. Alright, so we've got OSPF areas, different area type, OSPF router types. Then we should know about OSPF neighbors and adjacency. So OSPF neighbor and adjacency, some key points. Let's make a note of it. So first is the neighbor requirement. So we must know, what are the different neighbor requirements should be met to become an OSPF neighbor. And for example, the routers, the interfaces which is connecting two routers should be part of the same area, right? They should be part of same IP subnet. Okay, they should maintain same authentication passwords, right? And should have the same hello and dead interval, right? And the default values. So default value is for hello timer is 10 seconds and dead timer is 40 seconds, okay, which is for broadcast networks, right? For broadcast multi-access networks, right? Yep. So similarly, these are the different neighbors requirements you have. Then you should know regarding the states of OSPF neighbor formation. So there, when two routers are becoming an OSPF neighbor, it maintains multiple states. So one of the state is called as the down state, where no hello packets are being exchanged or received, right, from one another. Another state is called as init, where the hello is received but no bidirectional communications takes place between two routers. Third point could be it's two-way state, where communication got established, DR BDR election will occur here, and this will be part of multi-access network segment only, like broadcast multi-access or non-broadcast multi-access. So two OSPF routers are in, like, they have seen each other's hello packet, DR BDR election will happen in this stage, and it will occur only in any type of broadcast multi-access or non-broadcast multi-access type of network segment. Next is we have xstart stage, where in case of xstart stage, in case of xstart, the master slave relationship will be formed, right? Master slash slave relationship are formed. So who is going to start sending the LSA? It will be there. So down, let me write down one point for each. So no hello packets are exchanged in down state. Okay, as we say init. So in case of init, it is hello is received but no bi-directional communication occurred. Okay, two-way is communication, or you can say bi-directional communication is established. Okay, bidirectional communication is established, and you can say DR slash BDR gets elected at this stage, and it works only in multi-access network types like broadcast multi-access or non-broadcast multi-access. I should not say or, should say and. Okay, and extart, as I've told you, so between two routers, master slave relationship would be formed. Next stage will be your exchange, where the link state databases exchange will start. We can say LSDB, link state database exchange will start. Okay, at this stage, next stage will be loading stage, loading, where the LSAs are exchanged. Specific, you can say specific requested LSAs are exchanged at this stage. And next we have got full state, right? So it means fully converged. So two routers will be fully converged and the routing tables will be updated. Good. So number 5 important point is OSPF LSA types. So there are multiple types of LSAs that you must remember. The different types are, we have got type 1 LSA, which is basically called as router LSA, and they are part of inside an area only. So router LSA, which is part of within the same area. Then we have type 2 LSA, which is basically called as the network LSA. It is generated by DR in broadcast multi-access networks. Okay, next is your type 3 LSA, which is basically called as summary LSA, and it is generated by the ABR to other areas, informing the multi-area OSPF routes. Next, we know that we have type 4 LSA. It is called as ASBR summary LSA, and it is generated again by the ABR. It is generated again by the ABR to indicate the presence of ASBR, and it will inform the router ID of the ASBR. Okay, and also the cost to reach it. Similarly, we have type 5 LSA, which is basically called as external LSA, which is where the ASBR will advertise the external routes by doing redistribution. So when the ASBR does some sort of redistribution and informs in external routes into your OSPF domain, so those routes becomes type 5 routes, and they are called as type 5 or external LSAs. Next we have type 7, and I'm talking mostly about IP based network, not multicasting or not OPEC LSAs or MPLS based LSAs. So we talk about the LSA types with respect to IPv4 based networks. So we have NSSA external LSA. Okay, so in that case it is used in NSSA area type. Okay, so type 5 routes will be converted to type 7, and it will be only there inside the NSSA area type. Okay, likewise we have got another concept called as OSPF network types. So we have got multiple network types that we must know about OSPF. So the different types are, we have broadcast multi-access based network type, so which is, and it will use DR/BDR election, and example could be Ethernet segments. So the routers are plugged with Ethernet segments, then those network types, OSPF will treat those Ethernet based links or interfaces as broadcast multi-access and multi-access network type, and over those type of segments DR/BDR election will take place. Then we have non-broadcast multi-access network type, which is also called as NBMA. It needs, first of all, manual neighbors So in case of annual neighbor configuration, in case of NBMA, because it does not support multicasting over here by default, and example could be frame relay based type of networks. Okay, next we have point to point network type. So in that case, make sure that no dr/bdr election happens in case of point to point network types. An example could be PPP based interfaces or serial links. So whenever the routers are connected with PPP based network interfaces or SDLC based protocol over a serial link cables, then it is considered as point to point network type. And we have another one called as point to multi-point as well. So it is again in point to multi-point, no DR/BDR election take place, and it will treat as multiple point to point links. Okay, and we have other types. If OSPF is running for loopback interfaces, the network type will be treated as a loopback network type. If it is running for virtual link based interfaces, network type will be virtual link. Yeah. So seventh one is regarding OSPF authentication. Some key points that you must remember is it supports null authentication, or basically no authentication. Okay, then it supports something called a simple password based authentication, where the password is sent and received in authentication process as plain text. Okay, which is very very insecure when you think about it. And next is your MD5 or SHA based authentication, where you can say secure, hashing based authentication will take place over here. Okay, last but not the least, we'll talk about the OSPF advantages that we get is definitely fast convergence, or can say faster convergence. The word convergence means if any new network gets added or any existing networks gets deleted, how fast OSPF takes that to inform the OSPF neighbors. So how quickly the OSPF neighbor routers within that area or between the other areas, they learn about those changes. So it is faster as compared to other protocols. Scalable, that's a very important term. So it's scalable with multi area design factor. Okay, and important thing, it supports VLSN based networks and also supports CIDR, that is supports classless routings. And other important feature is it uses incremental updates. That is, it will send only the changes, not the entire routing table each time. Okay, so these are one of the important features that you must remember as a network engineer regarding OSPF concept. So note these things, this is very important, and I'll be attaching this in the resource section so you can have a look into this whenever needed. Now regarding OSPF configuration, let's work around this with Palo Alto firewall. So what is my take over here with OSPF configuration is, so we will look into this inside area. So you can see the Palo Alto firewall will have a couple of loopback interface. It is running on Ethernet 1/1 on this inside IP address, connected over this LAN switch to this inside router having 10.1.1.25 IP and these two loopbacks. So I want Palo Alto PFW1 should run OSPF within that inside area, and let's say this should run in area 0. Likewise, on this interface towards this edge router over this 123 subnet, let's say we also have OSPF, area 0. Okay, and we will advertise, we'll configure OSPF on this inside router, advertise its loopback and the Ethernet segment. We'll configure OSPF on the edge router, advertise its loopback 99 and this Ethernet segment towards the Palo Alto, right? And let's see that if the exchange of these routes take place or not, and we'll make sure that it is in the same area, right? So logically, if you look into the design aspect, it is just like that. So I've got a couple of routers. One is inside router, one is the outside router. We've got the Palo Alto firewall in the middle. They are connected with two interface to each other. Okay, so this would be your, will be your that inside router, right? This one is your the edge router. Okay, sorry, and this inside router is connected with couple of loopback address, as we see, loopback 11 /24 and loopback 111 /24. It is connected over this Ethernet segment on 10.1.1.0/24 network, over which the couple of IPs are given here as expected. So this will be at 201, this will be at 25, and this is your PAFW1 firewall sitting in the head office. This segment is on 123.1.1.0/24 network. On the edge router, the IP is .1. On the PA, it is the IP is .201 at the host part. And at the edge router, we have got one loopback, which is 99. And on the PA firewall, we have got a couple of loopback, which is 1234/32 and 5678/32. So we want that all those. So we want the entire routing to happen in OSPF area 0, right? So we are putting OSPF area 0 configuration here with all the three routers. So let's look into that. I hope it is clear. So let's look into the configuration as of now. So let's go ahead and do the config. So first let's go to the inside router. Okay, I see some duplex mismatch, so let's fix it up. On the global config mode, interface, which is E0/0, duplex is set to full duplex, and if I see do show IP interface brief, I have couple of loopbacks configured. I have got Ethernet 0 configured. Do show IP protocols. I don't have any protocols configured here, so I'll say router OSPF process ID is 1, and then I'll say router ID. Say manually I define this, so router ID say it is 11, and network say it is going to be, it will run for 10.1.1.0. define the wildcard mask of /24 and it's part of area 0, and the network is the loopback network in area 0, and also the network 111 in area 0. Perfect. So if I see do show IP protocols now, I can see that OSPF with process ID 1 is running, and it is routing for this respective 3 networks over here. And if you see do show IP OSPF interface brief, you can see that OSPF is participating for this respective 3 IP or 3 interfaces, the Ethernet and the couple of loopbacks. All right, done. Let's go and configure the edge router. So first of all, on the edge router, show IP interface brief, I must have that loopback 99 is configured and G00 is configured with the respective 123 IP. show IP protocols over here as well. I don't have OSPF, so let's run router OSPF1 router ID. It is going to be, let's say, as 99. Network is going to be the loopback wildcard mask, and it is in area 0. Network is 123.1.1.0 in area 0. That's it. Do show IP protocols. So you can see it is running with OSPF process ID 1, routing for this couple of networks, and do show IP OSPF interface brief. I can see it is running for G00 and loopback 99 interface as well. Let's go to the PA firewall 1. Let's log into the management IP. So over here I will log into HTTPS 192.168.1.201. So username admin, password is the one that I have configured. So my job will be now to configure OSPF on the loopback interface, loopback 0, loopback 1, and on Ethernet 1/1 and also on Ethernet 1/2 interfaces, right, which is part of these respective network segments of 10.1 and 123. So let's close this. Let's go and click on the network tab, click on interfaces. So I don't have those loopbacks, so let's go and create that. So I need loopback over here, couple of loopback. So let's say this is, as an example, loopback 1 2 3 4. Virtual router should be that default router that we have. Security zone is part of the trust zone. IPv4, the IP is 1.2.3.4/32. Since in Palo Alto, when you configure loopback IPs, it's only support /32 based loopback interfaces. Okay, likewise one more. It should be not in the same one. Select that, yeah. So advanced, I can add that management profile, which is allowing the ping for me. Click on OK, say yes to that. Looks good. Let's add another, which is loopback 5678. Virtual router is that default. Security zone is that trust zone. IPv4. So this is going to be 5.6.7.8/32. Advanced management profile. Let's add that. Click on OK. Yes. And now regarding the Ethernet interfaces, so I should have a couple of interface, one on the inside, on the trust, one on the outside, on the untrust. The respective IPs are configured over here. Looks good. So next would be to go into the virtual routers. You can see that on the default virtual router I have all those respective 4 interfaces, right? Couple of loopback, couple of physical. When you click inside the default virtual router, then you can go ahead and click on OSPF configuration. First is to enable the OSPF process inside the Palo Alto. Click on the enable one. If you want OSPF to reject any default route, you can do that. That's fine as of now. Router ID, let's say you make it to 1 2 3 4. If you want any BFD profiles to be there, you can do that. Areas, let's add the area ID. So click on add, and area ID will be in 32-bit format. So I want it should be in area 0, so it should be area 0.0.0.0 format. If you just give only 0, it will highlight you with the red, or it will say the hey, it is invalid. So it should be all zeros like that. Now depending on your requirement, you can change to normal, stub, or NSSA. Mine in that case is normal as of now. You can define the IP address network range, you can define interface, you can define virtual link, configurations if you need it. So let's click on interface and click on add, and I add Ethernet 1/1. I enable that. Let's keep the default metric, default OSPF interface priority. authentication profile. We'll add this later, and let's keep the default timers over here. Okay, since it's in the link type, you can see it's broadcast multi-access, but if I want, I can change to point to point or point to multi-point. But let's say if it is, let's say it's broadcast multi-access as the default one. Click on OK, click on add, select Ethernet 1/2. Let's keep everything default. Let's go and add the loopback interface, but make sure for when you add loopback interface, you need to select this as a passive, otherwise it will throw you an error saying that when OSPF runs for the loopback interfaces, it must be enabled as a passive mode. Okay, all right, keep the remaining values as default. So loopback 1 2 3 4 is part of the OSPF process now, and the interface is 5 6 7 8, enable passive. Looks good, perfect, and click on OK there. So yep, if you want in authentication profiles, you can configure that, export rules, advanced, yeah. So as of now, it's just running OSPF in area 0 with the respective interface based networks, and click on OK. Let's go ahead and commit the respective changes. Commit all change. If you click on preview change, you can also see what changes will be applied to the running config. So you can notice here, so these are the respective OSPF configuration that is going to be enabled. Okay, all right, so let's click on commit here and wait for the commit to complete. So it's almost done. Okay, so you can see it's committed successfully. So let's click on close. Now what you can do is, you can go back to the inside router, and you can see that notification where it says that, hey, there is a neighborship with the Palo Alto firewall whose router ID is 1234 for the OSPF process, and it's fully adjacent. That's the edge router, and also the inside router, it says it's fully adjacent with the PA firewall. Now the inside router, if you see do show IP OSPF neighbor, you can see that the PA firewall is listed as an OSPF neighbor, and it is fully adjacent, and the neighbor interface is a BDR, so I'll be the DR on my segment. And if you see do show IP route, but only the OSPF routes, and you can see that you're receiving 99 and also 123 network, and it shortly will be receiving 1 2 3 4 and 5 6 7 8 as well. Okay, just wait for that, it will appear. Edge router, so if you see do show IP OSPF neighbor, so it shows the PA firewall as an OSPF neighbor, and do show IP route OSPF, it shows that 1 2 3 4 and 5 6 7 8 as your OSPF. So you're getting the routes to the PA firewall loopbacks are appearing here, and you can see 10.1.1.0, and also the router loopbacks 11 and 111 is appearing on the edge routers, right? So the outside router knows about the inside OSPF routes as well. Okay, yep, so everything is fine. Let's say the inside router, can I reach from the inside router? So I should have a security policy on the firewall that allows the traffic from inside to outside. So let's look into that. So look into the policy first, and then let's look at the security policy. It says from trust 10.1.1.0 to untrust to any address, any application. Yeah, so let's say that we modify the security policy a bit, and let's say we define the source as any. Okay, as of now, so let's delete this as of now and just keep it as any as the source address. Okay, destination is untrust zone, any destination address, application is default application with default port numbers. All right, so click on OK there, and let's do a commit one more time, and then we'll do the testing. Okay, so the configuration is committed successfully. Close. So now the point is, I can do the testing from inside to outside. So let's go to the inside router and try to ping 99 with a source of say 11, and that should work perfect. And likewise I can also reach that outside router loopback with source of my loopback 1. Okay, so it should be due because I'm from the global config mode, so it's working like a champ, right? So next topic would be, over here I can add up OSPF authentication. Okay, so let's say first I do the OSPF authentication. So my requirement is between PA firewall to the inside router, I want OSPF to have authentication, but between PA firewall to the edge router I do not want any OSPF authentication. That means my edge router should not receive any OSPF route from my inside networks. Okay, so let's go ahead and make it happen. So to configure authentication, first of all I have to go to the PA firewall and go to the network, go to the virtual routers, click on the default virtual router. Inside OSPF I've got this authentication profile, so when select that, let's click on add and add the authentication profile. Let's name it as OSPF underscore auth. Let's say it's all uppercase. I want to have MD5 based authentication. Click on add. Let's say the key ID is 1 and the password is Cisco123, all in lowercase, CISCO123, all in lowercase. Click on OK and click on OK there. So the auth profile is configured. Now you have to go to the OSPF area ID, click on the interface. So make sure that we enable authentication on all those OSPF interfaces. Yeah, so let's look into that. So let's look into it1/1 should be part of that authentication profile. It says none, so the inside interface should have this auth profile, as well as the outside interface, which is it1/2, should also have this authentication profile configured. Okay, click on OK there. So our profile is applied on both the interface of it1/1 and it1/2, and will run authentication only on the inside router, so that the inside router and the PA firewall can exchange the OSPF routes using authenticated process, but will not configure any authentication on the edge routers, so they will not run authentication to the PA firewall, and the edge router will not receive any inside routes. All right, so let's commit those respective changes. If I see the preview change, make it to line 20 in single context, so I can see that, hey, right now authentication profile will be added, and I can see on both the interface it will be added, right? And this is the authentication profile configuration that will be added. Good. Click on commit. So let the commit happen in the backend. In the meantime, we need to go ahead and configure OSPF authentication on the inside router. Just a second. So I'm on the inside router, and first of all I should go to the OSPF process, and I should say authentication for area 0. So I should say area 0 authentication, and I want the type to be message digest, and then I should go to the respective interface, which is here Ethernet 0/0. Okay, and yeah, see, I told for area 0 I'm using authentication as MD5, but yeah, since I'm not running authentication on the PA firewall, so yeah, so I didn't define the key, by the way, so it is the neighborship is down. Anyway, let's go and configure and bring it back. So it interface Ethernet is 0/0, and I should say IP OSPF authentication as message digest, and then I should say IP OSPF the message digest key, where the key ID say it is 1, and I should say type is MD5 and the password is Cisco123. all right, So I hope this is enough. Yeah, this should be fine, and I should get the OSPF neighborship to be back. Here we go. The OSPF neighborship is back. All right, and if you see now, show IP route OSPF, all the routes will appear shortly, so hold on for that. Show IP OSPF neighbor, your neighborship with that show IP route OSPF. Yeah, you're getting the routes, so it will be appearing shortly, all the routes. Hold on for that. And the edge router, it will be down, and you can see since I've not applied any authentication on this edge router, so if you see do show IP OSPF neighbor, it's not there. Do show IP protocols, protocol is configured, but will not receive any OSPF routes. IP route OSPF, nothing, right? So we can, you know, do this, right? Perfect. I hope this particular points are clear. So now you can see that, you know, you cannot go for, you know, the inside router. Now it cannot access the outside network because you don't have the route. So if I look for the inside router, do show IP route, you know, I don't have any route. So I've got a default route, which is no, so it's for the edge router, I'm sorry. Do show IP route complete routing table. Okay, so I have my static routes towards, okay, so I have to remove that. That's the reason why it was not appearing as an OSPF route. So no IP route 1.2.3.4 with 32, and no IP route to 5.6.7.8. do show IP route OSPF. Yeah, that's fine now. So 123 is appearing, 5678 and 1234 is appearing as an OSPF route on the inside router. Perfect. Yeah, but the point is, you know, do show IP route. I don't have a route to reach. I have my own, you know, internal area. I have got till 123 network, but you know, now if I want to ping to 11, sorry, if I want to ping 99 with source of 11, this will not happen because, you know, neither I don't have a route to reach it, neither the edge router knows about, you know, my local stuff. So yeah, because the OSPF, you know, routes are not getting exchanged to the edge router from the Palo Alto firewall. Yeah, so I hope this particular configurations are up to the mark and you are clear on how to configure OSPF and configure OSPF authentication on a Palo Alto firewall. So thank you for joining. I'll see you in the next lecture. Thank you.